Here's a quick lesson on exact trigonometric values, one of my favourite topics. You begin with an equilateral triangle of side 2, 2, 2. Now, because it's trig, you need some right angle triangles going on, so drop a vertical down, like so. So it was 2, 2, 2, it's now 2, 1, and you don't know what this is. Use a bit of Pythagoras now. So Pythagoras said, if you square the sides, which are touching the right angle, they give you the hypotenuse squared. Okay, so play around with this. Okay, so the height of this triangle is √3. Pop that in there. So let's draw our triangle out that we're working on now. So it's the equilateral triangle, but we've chopped it in half. Now, as it's an equilateral triangle, that must be 60. But the one at the top must be 30. Oops, sorry. So you can now work out sine, cos and tan. So if you remember your SOHCAHTOA, then sine 30. So sine is opposite of hypotenuse. So I'm looking at 30. So opposite over hypotenuse gives me a half. Cos 30. So focus on the same angle. I'm here. I'm doing cos, so it's adjacent over height. And tan 30. Okay, so tan is opposite over adjacent, so 1 over √3. Of course, you could rationalise that if you wanted to. And you can do the same sort of thing with the 60s. So sine 60. So I'm now down here, sine 60, so sine is opposite over height, so √3 over 2. Cos 60 is adjacent over height, so 1/2. And tan 60 is opposite over adjacent, so √3 over 1, in other words, just √3. Okay, so that's how you do your exact values for 30 and 60. Okay, so that's 30s and 60s for sine, cos and tan, which you're supposed to remember. I don't ever bother, I just draw the triangle out. Now we're going to look at 45-degree angles. So let me just rearrange this. So this is a right-angled isosceles, right-angled. There's your right angle, isosceles, because you've got two sides the same length, which means that these two angles must be the same, and they must both be 45. Think about why they must be 45. Again, you're going to do your SOHCAHTOA. This one's much quicker, because you've only got one angle to muck around with. So you're going to do sine 45, cos and tan. Apologies about the writing. So sine is opposite over height. Now you can use either 45, it doesn't make any difference. So sine 45 is opposite over height, so 1 over √2. Again, if you wanted, you could rationalise that. That'd be a good thing for you to do. Cos 45, adjacent over height. Notice you get the same, think about it and you'll realise why. And tan, opposite over adjacent. Opposite over adjacent, 1 over 1 to give me 1. So that one's much easier. Again, you're supposed to remember these. I can't remember them. I just redraw the triangle. Okay, I hope that was helpful.